Good afternoon, folks. Today we'll talk about a problem that I see too many times, that when we start working and we go to conventions and people say, how can I do that for my system, for my database? And people say, you don't have to work about your database if you have a good layer of your model. But for me, that is just a way of dodging the real problem. And I want to talk to you about some problems I face while working and some possible solutions. But first, who I am. I am from far away. I'm Brazilian. I am majoring in digital game development, but I don't work with it. I'm a senior software engineer in a company called SCUP. We are a social network aggregator focusing on customer services for companies. I love Legos. I really love them. I have almost 25,000 pieces of Legos. Those are some of them. I don't have this one yet. I have the Volkswagen Vintage, the Simpsons house, and the Darth Vader. The Darth Vader is awesome because he's like he has a flashlight built in, so it's nice when your power goes out. Yeah, but now that I established my not so awesome credentials, what you're going to expect from this talk? You're going to need to learn to raise your options, because it's a legacy application. There are usually some things coupled into it. You can't take a decision by yourself. You need to take your to talk to stakeholders, and even sometimes if you're owner of the company, it depends on your size. You see my definition of spaghetti code versus legacy code, and some real-life examples. But first I want to talk about respect. Not about people respect, but about the application itself. But if the application is too old and is still running, it's because there is a reason for it. Usually it's money. What? Usually it's money. In some way, sometimes the application is making the company a lot of money, and sometimes it's making the company don't lose money. And they don't wanna change stuff like that because they are afraid of it. I had a case. I work in an application that it was really the most zeros I ever seen in my life, and it was a high availability application. We couldn't do alter tables all the time. We couldn't do, well, like I say, creating new features on the fly. And all we have to do is like keep that going. And it was like you have a SQL and you have HTML on the same file. So it was not pretty at all. But as I said, it was getting a lot of money for the company. But why those two? I think there is some legacy applications that falls into the pink zone. For instance, Magento. For me, it's a legacy application. It doesn't change its architecture for a while. And you can extend and create new features. You can work with it. And you have the green area. There is like that application I work. It was the spaghetti zone. The middle area, it's all called the turn programmer crazy zone, because you get like this, too much stuff to handle it. So how they can be different? Legacy applications may be no longer supported, may have a development freeze, and usually you have old technology like PHP 4, PHP 5.2, and MySQL 5.1. Spaghetti code, you have a Django structure. You may have current technology, And you have too many bugs to track, because when you fix something, you break another. It's always that. You don't have TDD. You can't implement TDD in a spaghetti code. It's practically impossible. And I never saw a crap application with a good database design, but I have saw some good applications with a bad database design. Sometimes it happens. So how do you optimize your database? Wait 10 years. That was Erlang creator. He said that in 1980, because he said at the time that Erlang was too ahead of its time, that computers weren't good enough to run it. So people would have to wait to see the powerful language. And that has to do with the Moore's law. It basically says that every year you double the capacity of your processors, so you can have a vertical scaling. And for some people, just vertically scaling at your database, it's good enough, because you may have not that much of data throughput, and you not have that much of concurrency on your database, so that may work for you. But in other cases, you may need to look for more horizontally solution. My first tip, I don't know if people was on the talk before, and I agree. You have to learn to use the structures of the database correctly. Every database gives you tools to use. MySQL, for instance, you have MyISON that reads really fast. And Postgres can store NoSQL and search into JSON fields. But since you're looking at documents, you may want to use MongoDB or CouchDB. Even Oracle and Microsoft have good tools to database. But one thing I see a lot is people using the structures in a way that they were not meant to be. Like, for instance, when you store JSON and serialize arrays and objects in the database. Usually when you do that, you're storing in a key-value manner. You're not going to search on the field. Do you know this table? I get it why they did that. It's an open source project. You can make stuff too much complicated. It's WordPress. But they're not wrong to use that, because they're not searching on the text field. They're searching the option name column. So just for key value storage. But text fields are an issue, as the database stores for each field a file. It's hard to get, it's hard to read from the disk. It's not that performative. Yeah, I have another example. That's something on my slide, that's okay. This is a binary tree. It's from that system I said that I work for. We had a binary tree there. And you have the user ID, you have the ascending path to the root, what they call materialized path. And this is stored in a text field. So the ascending path is a text field. You have a problem with size limit, because if you have a huge tree, you only have 4 megabytes to store it on MySQL. You have a low performance on search, because you need to do a like, and you don't want to do that on text fields. Although you can have an index on text field, but if you're using InnoDB, the length is limited. You need to tell how many bytes to search into that text field. Unless you are using MyISON, that doesn't need that, it's full text search. This database at the time was on MySQL 5.5. You didn't have the MySQL 5.6 yet. This is the graphical representation of that binary tree. And one of the problems was, I want to know where the number 1 is on the ascending path. Who has it in his network? you would need to do a like to do that search. The problem is it took 16 seconds to do that search. And it was a InnoDB table because we had transactions. I couldn't do my ISON there. So the web page that had this information took the website 3 hours after we could go up the application again, and 3 hours later it was down again. Because we had 5,000 people accessing simultaneously the application. So 5,000 people doing a query of 16 seconds and doing refresh because it's not going to show them. It's going to be slow. But I did something that was pretty simple. I added another filter because I was always going to show 4 levels of this tree. So I would say to the database which levels I wanted. And with that, I went from 16 seconds to 0.3. I can show you that. Wait a moment. So this is the first query. Oh, I'm sorry. Oh, thank you. So this is the first query. Can you read it? Let me see. There's a presentation mode. Okay. This is a better server. I changed it. At the time, it was taking 16 seconds. Moore's law. And this one. Actually, it is inverted. It took 0.2, and this one is still running. I should have run the one first. We get the result. And 13 seconds. After that, it was 51 times faster, just because I added another filter. So sometimes you may have a way of improving your database performance just looking in your business logic. It was what I did. But there is better ways to store hierarchical data. If you're using a relational database, you have the adjacent list. It's the same data. Instead of 14 rows, I have 7. And for each row, I say who is the left node, who is the right node. The problem is to make that search now, you have to have a lot of inner joins if you want to do that. But I think it's still better than the like on the text field. If you can't use another tool to do your job, you can use Neo4j. Michelle knows better of Neo4j, but this would be the graphical representation of the same data stored in Neo4j. So what's to learn? If you use the right structures, you probably won't have much problems. If, for instance, if you want to store money, you use decimal. You don't use float or double because it can change if you change your server because of the floating point. Avoid like in statements, please. Like statements on text field because they can't be indexed in a fast way from the database. Review your query. Sometimes the problem can be easier than doing some changes that you think it was needed. And different tools have a trade-off. Since I was talking about Neo4j, you would have to learn how to maintain a service like that. You have to have someone in your team I don't know, a DevOps, or even yourself, but you would have another responsibility to add to your application. So this is one thing you need to always think about it. Can I take care of that later If you don't, you have to use the adjacent table. It's the same infrastructure, but you wouldn't have to add another responsibility. I have another query. This one is from the same application, but this one is about money. It's transactions. So every time someone bought something, someone would win something because of that. And it's like affiliate program. And when you mess with people's money, they want to see everything that's going on. This would take the application down as the other one, but this one was the more critical. And I was given 2 days to solve it. This is the query. How long does that query take? It shouldn't take that long because you only have 2 inner joins. And although you have the filter using text, this is Aversion. The guy who did it didn't know about dimensional tables. And as I said, I couldn't do an alter table because alter tables in MySQL locks the table. And we had like 5 transactions per second. I couldn't do that. So that query takes 8 seconds to run. I can show you after. I want to show you something first. So, as I said, you have a foreign key, primary key relationship. You have a varchar field as a filter, and this field is indexed. You have an order by using date time, and this field is indexed in a descending manner. But I have something to tell you. This is from MySQL documentation. Descending, the instruction of being descending outer table, it's parsed but ignored, which means MySQL doesn't have a descending index. Yeah, I felt like that, but worse. I was very angry because I had 2 days to solve it. And the advantages of working with different companies I work with a lot of different databases. I work with Firebird and Oracle and SQL Server and Postgres. They all had descending indexes. Even though if you have an ascending index, the database was intelligent enough to reverse it and do the search for you. But it's not the way. In MySQL 5.6, when I was trying to replicate the problem to show you, after I left, there was already MySQL 5.6. We had upgraded the server, but we already had solved the problem. Another way we didn't know that, but the index is a little bit faster now in MySQL. So that query that took 8 seconds was taking 3. I was like, what? They were going to think I'm lying because it was Moore's Law again. But we decided to do something. We decided to cache that query. But I couldn't cache in Redis, for instance, because every user have a different query. And I couldn't use Memcache for the same reason. So where I would store something like that, that would need to get updated all the time. We decided to use a document database to store the table just as a replica, to be able to read from it instead of reading from MySQL. We did the same QueryMongo. This is the QueryMongo. Same one, you have the data range, you have the search with the in and the users. It takes 35 milliseconds. Now, I was told that 35 milliseconds in Mongo, it's low performance. That there is queries that take 3 milliseconds to run there. And I am not a Mongo engineer. I did that installation by myself. So getting from 8 seconds to 35 milliseconds, I wasn't angry at all. I was really, really happy. So again, this is the MySQL query. This is the Mongo query. They're pretty much similar. They're pretty much the same. The index on Mongo works in a descending manner. It works. And on MySQL, it didn't. I needed the newest transactions. I needed to be descended. So, what is to learn now? MySQL has faulty descending indexes. Sometimes you need to use another tool to solve your problem. And as I said, there is a trade-off there. I want to show you something again. This is that query I showed you before. Let's see. I was told I should do a dance right now to make the query run. I hope it takes less time. Done. Yeah, done. 13 seconds. And what I want to show you is this. When I found the query on the database, it was using the primary key or the by field. And usually the primary key is a good index because it's always indexed and you can search it for it in a very fast way. But in MySQL documentation, it says that the primary key works in mysterious ways. It doesn't explain how, but ordered by this index, it's not simple as they should. And if you do an explain, it's going to show you the same information. So ascending order, this is a server with 16 gigabytes of RAM. I have 8 million records on this table. 13 seconds. I'm afraid of running the descending now. It's going to take like 60 seconds. Or I could be trolled in last time. Uh-oh. It was the same time. I think the first time. Let me see. I have query cache disabled. Yeah, it took more time. Okay, I'm sad now. But at the time, it took less than 1 second to run it. And I want to show you that when I ran if date transaction, that was this one. Okay. Yeah, not good, but that's okay. 13 seconds, okay. Yeah. I apologize for that. So we came from a 13-second to a 35 millisecond search on another database. How did we do that? There is 2 ways. As I said before, you have your legacy application that may have been well organized, as I was a code again like Magento. It's not the perfect application, but it's really organized. And you can have the spaghetti code. If you do the passive version, It would be like that. You have your application and you have your data. Oh my God, I'm sorry. Nobody told me. Why is that? And you would need to use two tables for that. You have your already transactions table and a temporary table for you to know what transactions are pending from synchronizing. So your data go to the transaction table, go to your trigger. It triggers an event on the database that store that data in another table. And you have a cron job taking that and put into Mongo. But again, I had 2 days to do that. It was the fastest way, and it's still the way that is working until today there. But if you have a good application that's just old, you can do stuff like this. You can have your data, save into MySQL, send it to RabbitMQ, for instance, and save into Mongo. That would be nice because you would have the most recent records would be on the Mongo, and the other would depend on how much the cron job took to run. You don't want the cron job running twice at the same time, and the trade-off may be a little better at this case. But if you have like several places on the application doing inserts and updates, you can't do this unless you're like trying to map every place of it and add a line to send it to the queue. The best solution may not be the textbook solution. The solution that is best is the solution that is working for you. And that fancy solution may be overkill because this stuff, it's not cheap either. You need an infrastructure to make that work. And if your application, it's old, but it's small, and you don't have a lot of people to take care of and help you with that, you may just go through the easy path that is a simple cron job that anyone can set up. Another thing that I wanted to share, I don't know if you saw that book about database refactoring. It's one of those Martin Follows series. And it says that for you to make a change in your database, like get a field from one table and put in another, you would have a 2-year deprecation period. Like in 2 years, I can do a new application. That's why I say that the textbook solution may be not the best solution for you. This thing is one thing that I learned, and I am trying to implement on the company, but it works. As I said before, I couldn't change. I had some problems with alter tables because I had a lot of data on it, and usually the other speaker that was before me said, if you have a text field, a document, a JSON to store, save in another table. That's usually a good advice because if you have to do another table, what MySQL does, it locks the table, copies the table from the old to the new one with the new fields or new indexes. But if you want to do that, if you want that table to be searchable, you will probably use something like Elasticsearch, or you're going to store the document part on a NoSQL database. You can get it directly from the database, so you would have your application saving the data on any relational database at all, and use one of the services to search on it. Probably a lot of people use Elasticsearch. At my job, we use Cloud Search. But it's the same. It's a Solar implementation from Amazon. It works the same way. And one thing that I was looking this week was that you can't skip the database part at all. You don't need it. to store your documents. You can, it's working? I don't know. You can keep the database part at all. You don't need it all to store this kind of data and search for it. You can store it in a text file. Since a text field in MySQL is a text file, why the text file can be anywhere else? It is the same thing in a low level. So for instance, if you're, I get those because I work social media. So usually my documents are feeds, Twitter, Facebook, an RSS feed. You can use the application to get the data. Save the data in a bucket. A bucket is a CDN, a content delivery network inside Amazon. And use the same infrastructure to get that text into your search, in your cloud search. But you can use that in Rackspace or any other, like Akamai or other CDNs, and make Elasticsearch search for the file there too, because actually it only imports to them the document, not how you get the documents. And this kind of works. I have another demo here. So this is a little demo that I made. Someone has an easy Twitter handle there. What is your Twitter username, someone? Please, just say. Anyone, just say me your Twitter username. Huh? Noxy. I already have Noxy here. Well, let's see. He's already in here. What's yours, Anne? Huh? DA? Is that? Okay, let me try mine. Mine is not here. No. It's local, it's running local, and saving to the cloud, so it's going to be a little slower. Conference Wi-Fi. Okay. I'm using Opera because I'm mad at Google, so don't judge me. I don't remember what my last tweet was. Let me see. PHP Brewery, London. I'm just gonna search by London. Here, same tweet. I didn't pass through any database at all. I just saved the text file into Amazon S3, and Cloud Search got it from it and indexed it to make the search. So you can use it the same idea. You can get those documents out of your table, so you gain performance, and you can even like save disk space sometimes. Because at our case, for instance, our disk is the most expensive part of the server. And this is a good way of doing, because we already have the data indexed on the Cloud Search. But before, we would have to search into Cloud Search, get it from the database, put on the Cloud Search, get the Cloud Search ID, and go back to the database to get the data. It's not too many steps, and you can decrease your concurrency on your database with that. What time? And let me go back to the presentation here. You can add an extra layer for search purposes. So if we're going to do full text search I usually say anything that a user types in, you shouldn't be storing in a database. If it's a text field, it shouldn't be on the relational database because you're not going to do a inner join with that field. You're not going to relate anything with that field. You're just gonna need it because you need to retrieve it, but you don't have the actual necessity of this data being there. And it can be a huge save life when you have tables with billions of records. And try to use text files. CDNs are usually cheaper, and you have Elasticsearch. You could try to integrate into it. It's not that hard. Usually, you have good APIs. I will share my demonstration on GitHub if anyone else wanna see it. And to finish it, always analyze your trade-off. And the structures need to be used correctly because it is where you get your data consistency. Simple solutions can be the perfect ones. You don't need to do fancy, but at my last solution it was a little fancy, but because I found it awesome when I found out, I wanted to share. And try sometimes to look in your business logics. Much of your problems sometimes is because you don't understand how your business works, and you do stuff without knowing how you're doing, if it is the right way. I would like you to please give a feedback and joining for me. This is my Twitter handle. I want to thank you, DigitalOcean, for giving me the server for doing these demonstrations. And that's it.